In this video, we're going to talk about how we find the equation of the graph of a line. In other words, I've got a picture here, I've got a line, but I want to know what equation generates this line. So I'm going to read the problem, and then I'm going to try and figure it out. And there's a couple of ways one can go about this. The graph shows the distance d a train travels in time t at a constant speed r. Write an equation in d equals rt form that models this situation shown. In other words, the distance this train travels in miles, which is on the y-axis, is determined by the rate of speed that the train is going for a certain amount of time. And that makes perfect sense. If a car is traveling at 50 miles an hour for 3 hours, we know it goes 150 miles. So the question is, what do you need to do here? Well, what you need to do is you need to figure out what operation is being performed on the x value to generate the y value. And this problem is written in this form, d equals rt, which is a variation on a form that you're going to be using a lot, which is y equals mx. And what you're trying to figure out is, what are we, in this case, multiplying the x value by to generate the y value? In other words, what do I do to the x coordinate to get the y coordinate? So let's see. I'm going to make a table here. And in this case, my y is distance. So I'm just going to write d. Pardon me, I'm going to switch that around. I didn't mean to do that. My x, as you can see, is time. So I'm going to write a t here for time. And my y would be distance, would be d. And I'm going to use capitals just because it's easier. All right. And now I'm going to look at this graph, and I'm going to look for a point where I can easily see the two factors meeting. In other words, look, if I go up the one line, notice what I see. Right here, at this point, perfectly, I can see what's going on. Look at that. For 1 hour of time, I do a distance of 100 miles. All right, let's go to 2. Where does that go to? Lo and behold, I do 2 hours worth of time. I'm traveling 200. Okay, so for 1 hour, I went 100 miles. For 2 hours, I went 200 miles. Let's just do one more point here. If this is consistent, and I've got a ratio here, right, and I believe that I do, it's constant speed, then when I get to 3, it should be at 300. And sure enough, we can see that it is. All right. So that's our information. Now, how do we turn this into a graph, into an equation from this graph, from this information? Well, what it looks like to me here is that d, and now I'm going to go back to the lowercase, sorry, equals what? What do I have to do to t to generate d? Well, it looks like I multiply t by 100 to get d. If I multiply 100 by 1, that gives me 100. If I multiply 100 by 2, that gives me 200. And that, as you can see, is what is going on with this line. So distance is equal to 100 t. In other words, for any number of hours, if I multiply it by 100, that will tell me my distance. So if I go over here to 4 hours, I should expect that to be 400 miles. I would go up this graph until wherever I would find the 400 line, and the graph should meet that point. And that's one example of finding an equation having been given a graph of the line.